All right, so I normally don't talk about vaporware, but in this case, it's a lot of vaporware. We're doing a lot of work on the web front right now with Metasploit. You'll see the first results of what I'm talking about in about a month in the 3.50 release, but there's a lot more things happening. Basically, the point of this talk is that we're actually taking applications seriously from Metasploit development from now on. We've got some pretty lofty goals in terms of what we want to accomplish in the web space, and hopefully we'll get there, and we think we can do it. So this is kind of talking about where we are today, where we're going, what problems we're running into, and what we actually want to accomplish with Metasploit in the web application testing space. So first off, my name is HD Moore. Thanks, Neil, for the great introduction. Been working on Metasploit since 2003. Been doing security work since probably, well, depending how you define work, 95. If paid work, probably 99, 98, 99. I did tons of web app stuff a long time ago. I got out of it for a little bit, mostly focused on what Robert Hansen calls the elite memory corruption crowd stuff for a while, which is all the shell code and things like that, which is fun and interesting and all that. But when it comes down to it, most of our data is still going through web apps. Most of the things we care about from data are going through web apps. So coming full circle back again, we're actually bringing web apps into the Metasploit framework, into our kind of development and ramping that back up. So for folks who aren't really familiar with Metasploit, I know this is probably a crowd that is pretty familiar with it, but for folks who don't spend much time in that space, it was created in 2003 as an exploit development platform, and not so much an exploit toolkit, but a way for people to develop exploits quickly. And this becomes more important when we talk about the web stuff as well, because the thing that Metasploit really did over the last 5-6 years, and I guess going back even about 6 or 7 years, is turn kind of exploit development more mainstream. So prior to that, exploit development was really more of a black art where unless you knew how to write every little nibble of assembly code and do your own encoding and everything else, it wasn't really an accessible technology. It wasn't something that your everyday guy could just pick up some code and work with. We think that's changed. We think we're at the point now when Stack Overflows, SEH overwrites, heap overflows to some extent are actually to the domain that anybody can actually sit down and do it with enough time. These aren't things where there's no limit of information available for it. There's tons of examples available. We've got over 600 exploits in Metasploit today that demonstrate how to do it. So we feel like we really helped folks develop their skills in terms of developing exploits, and we've helped a new generation of folks who didn't have kind of the hardcore assembly background get into exploit development and really realize what the risks were with this type of vulnerability. It's still the largest Ruby project in existence. We rewrote the project from Perl to Ruby back in 2005. The rewrite took us about 1.5 years, and it was painful and miserable and everything you want to call it, it probably was. We had to port over 45,000 lines of code as well as something like, I think at the time, 300 exploits. So tons and tons of things broke. It took forever to get it all done. After we're all said and done, we took our 45,000 lines of Perl and turned it into about 100,000 lines of Ruby. So it wasn't really compression at that point. It was more of an expansion. Since then, we're actually over 450,000 lines of Ruby code. We've got 6 developers, about 6 full-time paid developers, about 100 contributors over the life of the project, and about 15 people in the community that contribute heavily enough to get listed on the front page. The idea behind Metasploit is that instead of having an exploit where everything's hard-coded into it, like for example your target addresses, your shellcode, your payload, your encoders, your attack vectors, your transports, instead of having the same piece of crap C code that has the same functions in it again and again and again and again, the idea is that instead everything's broken out like Legos. So we give you a set of modules, a set of payloads, a set of exploits, a set of encoders, a set of NOP sleds, and it basically at runtime, it puts all these pieces together to build an actual attack. And that attack is different every single time you run it. The shellcode's completely different, the encoders change, the keys change, the NOP sleds change. It's going to be as random as possible, basically to make sure that your AV product is actually functional and not actually, just catching a static signature. And we also had tons and tons of new exploit modules. So if you've updated in the last day or two, you probably saw the new PDF 0D that's going around. We had the exploit taken apart, disassembled, and put back together again in a nice, clean, testable form in about 2 hours. And that's basically par for the course for us for 0 day. So when something crosses the wire and people are talking about how dangerous a particular exploit may be, or whether it's something that you should care about, or that your AV may or may not defend you against, your IPS may or may not defend you against. The role of Metasploit is really making sure that you can test that, you can verify it, you can make sure that if your vendor is telling you, oh yeah, we blocked the new PDF 0 day, prove it, make sure it actually works. And we do all that for free as part of our free offering and free products. So historically, Metasploit's really been tightly focused on shellcode itself. We've been looking at things like assembly and encoders and NOP sleds and heap overflows and all sorts of fun, kind of low-level stuff. We really focused on server-side exploits for the longest time before those died and there aren't any fun ones anymore. Now we've kind of switched over to client-side applications, doing all the browser bugs, the browser exploits, all the other fun client-side apps out there, everything from your PDF readers to your media players, things like that. most of the really hard work on the Metasploit side has been on the low-level front, doing things like payloads and stagers and encodings. And the goal really has always been to take high-level languages like C and be able to use those as payloads within Metasploit. So you don't have to be an assembly engineer or a ninja to be able to write payloads for Metasploit. We started off with the DLL injection stuff back in 2004. We've since made that even better. So these days, if you know how to compile a DLL in any language, you can make a payload. If you actually want to use Visual Basic to make a DLL that has your shellcode in it, you can actually do that now, load it into Metasploit, and be done. So it's more about making parts of exploit technology more accessible to folks and make it easier to test out different techniques than it is about trying to have the most advanced technical zero-day spawning system ever. We've really focused on Windows code execution just because there's so many of them out there and it's lots of fun to play with. Windows is exploitable in so many ways that a real platform shouldn't be. It's the only platform I know of where if you actually have a chunk of code that it does a mem copy with -1 as a length offset and it copies all the way off the end of the stack and tries to write to memory that's not mapped and crashes, it's still exploitable. Now, a real OWASP, what would happen is it'll hit the end of the page, it'll throw a seg fault, things will crash, and you'll die. On Windows, you overwrite not just the stack frames, but you also overwrite what's called the structure exception handler on the stack as well. So when you run off the end of the page, it triggers an error. Well, the code that handles the error is pointed to by the memory you also overwrote. So that's why you see so many Windows exploit modules out there that are reliable when they shouldn't be. It's because of that one SEH structure, and it took a long time for people to realize that was the issue, and Microsoft's now addressed that with SEH op and some other implementations they've done, including safe SEH. So we love Windows because it's been our, for lack of a better word, our bitch for the last 5 years. So I think we're going to have to move on at this point, but it's been fun for a while. So we've got exploits for everything from Windows NT4 all the way to Windows 7. We've got exploits for Linux, BSD, SCO actually, BSDI, HPUC, Solaris, IRX, you name it, we like to exploit it. We did one of the first remote exploits for the iPhone platform, and actually we'll probably start working on the new one as well, because iPhone's fun. More recently, we've been working on the VxWorks embedded OS and working on exploits for that. So we're doing a lot of work on the embedded side and hope to have something really solid in the next couple of months. And normally I go way too fast, and I feel like I'm going slow this time, so I'll try to speed up. Metasploit under Wrap 7. Metasploit was acquired back in 2009, and for an open source project with a bunch of free code and no assets, being acquired is a funny term. Being acquired basically means I got a job. And a little more to it than that, but for the most part, it's basically, it looked like a good opportunity, it looked like a great way to make Metasploit my full-time job as opposed to my part-time job, and having a kid on the way, and now a kid that's 1 year old, it was a good opportunity for me to, see my family and still work on Metasploit. So overall, it was a really good decision. I think we're really kicking ass and doing a good job. We hired 6 developers to work on it full-time. We've got actually over 100,000 users are updating directly from the SVN head per month. So we're a really bizarre open source project in that we don't really care about releases so much, because most of our users, 100,000 users per month based on unique IPs, are doing SVN update directly off our development head and running our code. So we're really stingy about access to our source code tree because of that. So if someone's able to add an hour to the Metasploit tree, you can probably hit 100,000 people very, very quickly. So we watch that thing like a hawk. We've got all sorts of fun rules and restrictions in place and software that watches things. So we have a pretty massive user base for an open source project, let alone for people who are brave enough to run our development code. And by development code, I mean when I type SVN commit on a command line for a new exploit and it goes in the tree and it breaks everything, that breaks 100,000 users right away. So our developers have learned to be a little gun shy about commits and to make sure that, and not because of some policy in place, because it's we're not giving guarantees in open source software, but because they get so much hate mail afterwards from all the people they made mad by breaking the tree. So we've got a self-policing system at this point where as long as you don't break the tree, people like you, and as soon as you break the tree, your email flood starts until it's fixed. So it's a good way of doing QA in that sense, but the Wrap 7 effort has really helped as well. We've had over 100,000 lines of code in the last 12 months. We're at 10,000 commits to the 3x tree, so just a bunch of huge milestones in the last year that we've hit. We're over 600 unique CVEs and exploit coverage, which is comparable with the number of remote CVEs and many competitive pen testing products out there that are commercial. The big news is that we're shipping Metasploit 3.5.0 on October 12th, and that's where a lot of these changes and a lot of stuff I'm talking about web stuff in a minute are going to really focus on. So moving on to web applications themselves. Web apps are really rich targets. They're the juicy little piggy on the corner that just keeps on giving. It's like the bacon factory. It's awesome. Though web applications are the best target available for just about any organization just because they control access to your data. They're the gatekeepers for the thing you care about. The application has to limit access by user, well, the application has access to all the user's data. So at the very core level, what we care about is the data the application can get to and how can we get access to that data. That's the entire goal of a pen test for most web applications. And that may not be the database, maybe some other type of data. Maybe the data that's going through the web app while it's serving requests. So in addition to just having access to the data itself, the web apps have access to the database, whether that's local or remote. They open the door to doing attacks against the server itself and getting into the server, and then running around the network, owning stuff left and right. And more importantly, they let you attack all the users of that application. So this is something a lot of folks don't realize is when you're talking about the security of a web application and the server and you're hardening and this and that, if someone's able to actually put malware on the front page of your website through your web app, you can't patch your users. Your users will be exploited whether you know about it or not. I mean, there are some solutions for doing like outbound filtering from websites, but they're not going to be 100%. And when it comes down to it, your server shouldn't have been owned in the first place, but servers get owned. This happens. So what I find most exciting about web applications is kind of the multiplier value, where you'll own one machine, and then from that one machine, you can own every single user hitting that website for until they turn your machine off. So it's a really good way to multiply an attack vector, and it puts a lot more value on what may be an insignificant web server with a static web page than you may otherwise have. Most of the web application work we've done in Metasploit today has been focused on a bunch of static web apps, a bunch of PHP scripts that have known vulnerabilities, the TWiki software, stuff that we know is exploitable that have really clean, easy exploits, whether it's command injection, SQL injection, or what have you, or remote file includes, local file includes. We do have a couple of generic models that you can use with any vulnerability through a custom application. For example, you can take our remote file include module, tie that to a bug that you find in the wild, then actually get a shell of it. We do some integration with a tool called SQL Map, which is handy for doing SQL injection, but we just basically just shell out to it. What I'm basically saying is Metasploit just sucks for web apps right now. It's not good in any way, shape, or form. There was an effort to really drive web application development in Metasploit about a year and a half, 2 years ago by a guy named Efrain Torres. Really sharp guy who also just had a kid and works 80 hours a week. So we've seen a lack of development in WMAP for obvious reasons, and I can't really blame him being in similar situations sometimes. What WMAP is, it's kind of a loose set of about 30 different modules in Metasploit that all do various web scanning things, like directory scanning, brute forcing, vhost testing, custom 404 testing, all of your basic components and bricks of a particular web application. Like if you're building a web scanner, all the components you need to build a web scanner are part of the WMAP set today, but they're kind of all standalone little pieces that connect together to get the job done. It used to use the database backend to store the results of each individual test and chain them together, but since we've been on this breakneck pace in development since the Rap7 acquisition, the developer of WMAP hasn't been able to keep up with the changes that we keep making to the database. So the poor guy will come back around every 2 months like, okay, I'm ready to update. He's like, oh crap, the whole database schema is different again. Damn. So we're kind of a moving target right now in terms of the underlying DB schema, and he's kind of gotten a little disheartened lately because we keep changing pulling the rug out from underneath him when he works in this code base. It's been really focused on discovery and collection, not so much exploitation. So there are a couple things like the blind SQL injection stuff that's in WMAP today, but it's not really designed to get you shells yet. It has a couple exploits for RFI, traversal, SQL injection, but again, it's mostly designed to gather information for a deeper pen test or for a manual review. The goal of WMAP was to be able to take all these different individual components that are scattered in Metasploit as modules and automatically chain them together to get a job done. So it'll start off by saying, run the spider module, then take the spider results and pass it off to the directory scanner, then use the content discovery to find the applications, then crawl the content, then crawl the applications, find the forms, test the forms, find the bugs, run the exploits. That's the end goal for WMAP. So development has been a little bit tough for this guy just because we keep changing things out from underneath him, and with the kid and the full-time job and the travel, it's been a little rough. The DB isn't really in sync anymore. WMAP doesn't really function as a command anymore. You can run the modules by hand, but the chaining is basically dead at this point. Single developer, guy is awesome, but the guy is also really short on time. So he did add a crawler and a proxy tool directly to the framework. So if you want to build your own crawler, your own attack proxy, there's actually stubs already in Metasploit today for those. Those are under the tools subdirectory. They're not written as Metasploit modules yet, which is kind of a challenge with some of these we're going at. But the goal is really to kind of start building out attack frameworks and attack proxies and attack crawlers in the framework. But WMAP in general needs a big chunk of rework before it's really ready to be used in production. So we've got a couple of the missing components in Metasploit that really make web app testing today just not that great. We're missing a DB schema for the web results themselves. We keep changing things around, so we have workspaces and projects in various fields now that are different than they used to be. We don't really have a strong API for reporting results for web results specifically, like identifying specific vhosts, identifying SQL injection bugs. There's nothing really out there that is useful for identifying specific types of vulnerabilities and tracking information that you need to exploit these for web servers yet. We're missing a bunch of critical modules. Like we have a crawler, but it's a tool, not a module, and because it's not a module, you can't chain it, and a bunch of other things there. And also no